The DI Labs team can be passionate about many things, and one thing that we're especially passionate about is the automotive industry and mechanical things, and mechanical things that you can make better. And so this is a really unique application and a project that's for an automotive application. So this is for a European vehicle, a 6-cylinder European vehicle, sports car. But this aftermarket tuning shop wanted to put a supercharger on that car to make it forced induction and to improve the performance. So they had that as an opportunity, and they were faced with the challenge of, how do I create an intake manifold that can accept a supercharger and withstand the operating conditions of being under the hood, under high temperature, high performance vehicles. And so typically what manufacturers will do is that they'll cast intake manifolds, especially in pressure applications, because it's very high safety factor. Aluminum is well known in these materials, and casting is a great process. But in this early stage of development, the tuning customer of ours wasn't in the position to do that because they hadn't done the full testing in real life. So they brought us the challenge of, can you produce for us a functional intake manifold that will accept our supercharger and that will allow us to do real life testing? And so we looked at the problem, we evaluated the design, and then ended up coming up with this particular solution. Now this manifold is of their design, but what's unique about it is that the printer that we use isn't big enough to produce this part in its entirety. So what we did is we developed a splice, a functional splice into the part that allowed us to produce this manifold in multiple components and then splice it together with a mechanical joint, which is built into this section here, and allows us to deploy this manifold into a real-life pressure condition and have it perform well. So this is quite unique, and it's somewhat obvious if you look at it closely, but it's really not that obvious that it's a part that's produced from two different segments. So that was something that we focused a solution on to make sure that it had the aesthetic value that we knew that our customer wanted, and would also have the performance. We also included heat stakes into the application to allow them to mount their mounting hardware straight to the car. So this is all encompassing. So a common question that we get when we share this story with clients is, it's really hot underneath the hood of a car. Engines get really hot. And on top of that, if you're going to put pressure on the device, how on earth is it going to withstand? It's just plastic. How is it going to withstand those operating conditions? And that is a valid concern. It's a great question and a valid concern that we often get. And it really comes down to a couple things. One, the design, to ensure that the design is robust enough and it takes into account the material properties. And then the second is, and probably even more important, is the material selection, to make sure that the materials that it's produced in can withstand those operating conditions. We were able to additively manufacture parts using several different materials. And what we have done with this project is we selected one particular material, which is a glass bead reinforced nylon, for this application because of its higher temperature resistance and also its strength. So that ended up being a great material for this application. Every application is a little bit different, and what we'll do is we'll fine-tune the material selection and the design for additive manufacturing to accomplish the finished performance results. In this case, it was pressure and heat. So we'll produce the part in a glass bead reinforced material and ensure that we're using a process that provides us with really consistent material properties in the finished parts.